This is Josh White with JW Math Tutoring. Today's video, I'm going to go over 10 problems from the December 2024 Digital SAT Math section. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Just before I begin going through this worksheet number 2 of December 2024 Digital SAT Math problems, I just want to mention a couple things that I mentioned at the start, of each of these videos. First, obviously, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, these questions are self-reported, so there may be, some details if you got one of these questions on your actual exam, that's slightly different than what you see here. I'm just basically going off what people reported and sometimes having to make guesses about what the question's asking for or what it means. And also related to that, some questions will have multiple choice answers and some won't, but um, they could have had multiple choice answers on the test itself, meaning that some of these I'm going to do as free response, but if they were multiple choice, there could be additional ways to solve them that would be available to you. All right. So with all that being said, let's go ahead and get started on question number 1 here. This was a very common one that was mentioned a lot. Basically, you have an exponential function and the cells are increasing by p% every 150 seconds, and they want to know which of these expressions here represents the percentage increase for this given time period. So a couple things to keep in mind. First of all, the actual function is given where m, the variable, is in minutes, but this p% increase is in seconds. So we have to convert the 150 seconds to minutes, basically just by, you're really going to be dividing by 60 if you think about it, multiplying by 60 seconds on the bottom and 1 minute on top. So if you do that, it just comes out to 2.5. Okay, so 150 seconds, same as 2.5 minutes. All right, so with that being said, first I'll show you kind of the theoretical way to do this, and then I will show you an actual way to do it with picking numbers, which just confirms what the right answer is. So theoretical way, I would say let's start with m at m equals 0, and then let's compare that to m equals 2.5. In other words, we have our initial amount, starting amount at time t, basically like m time equals 0, and then after 150 seconds, we have some amount. We'll see how much it increases by. So if we do that and plug in 0 for m, notice you're just going to get 61 times q to the 0, but any number raised to the 0 power is just 1, so this is really just equal to 61. And then for 2.5, you're just going to get 61q to the 2.5 over 5, which you would just simplify to q to the 1/2. All right, so now remember, to find percentage increase, it's basically new minus old over old. Or you could also, instead of old, you could also think of it as the O standing for original, the original starting value. And then of course for percentage, you're going to multiply it by 100%. All right, so the new value is the 2.5 minute value, which is the 61q to the 1/2. The old value is the original value, the just 61, and then we divide by the original value, the old value, which is 61, and then of course, times the 100%. So first of all, these all have 100 in front of them, so we can essentially ignore this. Really what we're looking at is this part right here, which of these simplifies to something that we see in the answer choices. So notice what happens is each of these has a 61 in common. So it's basically like you factor the 61 out on the top. You get q to the 1/2 minus 1. You have the 61 on bottom. These cancel out. And now, and then times the 100%. Notice we have answer choice D right here. 100 times q to the 1/2 minus 1. So the correct answer for this problem is answer choice D. Now, I will just show you, you could also just confirm this or solve this in Desmos using actual numbers for Q. and then finding the percentage increase among them. So what I'm going to do is I'm going to, let's see here. Okay, so first I'm going to type the function. I'm going to let q, what did I pick? I just let q equal 2. Okay, and then for m, first I let that be 0 for my starting amount. Okay, so 61 is what I defined. I'm going to define that as O. 61 is my original or my old value. And now if I'm going to change m to 2.5. Okay, every 150 seconds, 2.5 minutes. Okay, so now I get this value. This is what I'm going to set equal to n. So I'm going to actually do that up here. So n is equal to 86.26, blah, blah, blah. So what's the percent increase if I start at 61 and I end up at 86.267, blah, whatever? Well, it's just n minus O divided by O. And of course, now it's times, 100 to turn into a percentage. So 41.42. All right, so now all we have to do is go through the answer choices and see which of these equals 41.42. And I can just type them in with the Q given. Okay, this first one is gigantic, so it's obviously not the correct answer. For the next one here, see, this is actually the correct answer, but really I'm supposed to be checking B next. Okay, 241.42, that's too big, that does not match. Then if you want to check C, change this back to a Q squared, now change this back to a -1. Okay, 300% increase, nope, way too big. So by process of elimination, you would recognize that it's D, but we can also see the values match. Okay, so the percentage increase I get, calculating it out using just picking numbers for Q, and plugging in m equals 0 and m equals 2.5 and finding the percentage increase according to the formula matches what you get when I plug in the value of Q that I chose to the different answer choices. So correct answer is just going to be D here. All right, next up we have a question that asked about density. So hopefully you know that density is equal to mass divided by volume. If you didn't know that, you can notice here they give you the density and you have a grams, which is a mass, on the top, and you have cubic centimeters, which is a volume on the bottom. So that's a clue, that you could figure out its mass over volume just by looking at the units. Okay, so we know the density is 2.3. We know we want to find the mass. Okay, that we don't know. And we're told the marble has a diameter of 33 centimeters. So we need the volume of this marble. So volume of a sphere, this is given on the reference sheet, but it's still good to memorize, is 4/3 pi r cubed. Diameter is 33, which means the radius is half that, which is 16.5. So if we just go ahead, punch everything in here, 4/3 pi times 16.5 cubed. That we're just going to do in Desmos. It should come out to 18,816.569. That's what's going to fill in here. Let's just go to Desmos to confirm. Slide this down. Okay, 4/3 pi times 16.5 cubed. 18,816.569 with some more decimals. Okay. So I'll let this equal to V since it's the volume. All right. So notice now with the solving for the mass, all we have to do is multiply by the volume on both sides. So the answer to this is going to be the 2.3 times 18,816.5 blah, 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 whatever. And that's going to give us our mass in grams. So I'm just going to take 2.3 multiplied by V. All right, there's my answer. And it says for this to round it to the nearest whole number, so 43,278. That's what the answer would be. To make sure I had that. Okay, 43,278. I have my digits transposed. 278. And technically the units would be of course, grams. Okay, so this is the number that you would fill in. If this is a free response, this is what you would type in for your answer. All right, next up, the bottom of the page, we have another exponential function here. And basically, they tell you that when you plug in 1 for x, you get some number as the output, as the corresponding y value, i.e. you have a point 1 comma k. All right, it wants to know which of these displays the value of k as the base or coefficient in the problem, where of course a and b here are just, positive constants. So the answer to this question is going to be letter B. And the reason I can tell that just by looking at it is because basically whatever the number is in here, for this type of question, you want the exponent to be x minus that value. So if this number inside here was 2, then we'd be looking for a function which had an exponent of x minus 2. All right. The reason it works out like that is because if you go ahead and you plug in 1 for x to each of these answer choices, okay? I'll just show you theoretically, and then I'll do it with actual numbers. The first one's just going to be AB. The second one, notice the 1 minus 1 is 0. B to the 0 is 1. The answer is just A. And that's why this is the correct answer, because notice K, which is the y coordinate that corresponds to 1, is just equal to A, which is a coefficient right here. So A happens to equal K. And if you look at these other ones, it's going to be AB squared and AB cubed, okay? And these are not coefficients anywhere or bases in the problem. So the correct answer is going to be B. Now, here's how you could confirm this just in Desmos. All right, so first thing, I'm just going to let A be whatever, 1.2, and we're going to let B equal 2, okay? Just any positive, values are going to work for this. So now, so we've got AB to the x, right? And then we've got AB to the x minus 1. I'm going to have to type out all these answer choices. X plus 1. And also I forgot I have to do one other thing, x plus 2. Okay, so what I'm going to do is just set these all up in function form. I'll explain why in a second. Okay. So now what I'm going to do is this is supposed to be f of x. There we go. All right, so now I'm going to do is I'm going to plug 1 into each of these, and I'm going to look at what the answer, the output is. And I'm going to see if that number is a base or a coefficient in the answer choice. Basically, what it's really asking for is that number equal to A or B? So for example, I look at the first one. F of 1 is 2.4. Is that a base or coefficient in the answer, i.e. is A or B equal to 2.4? The answer is no, it's not the correct answer. Then I check this one, 1.2. Is that equal to a base or coefficient? Yes, that is exactly equal to A, which is the coefficient. So that tells me it's the right answer. And you could also do this with H. Again, 4.8 is not the base or not the coefficient. Same thing here, 9.6, not the base, not the coefficient. Okay? So this is how you could do it in Desmos using actual real values, just to confirm that the answer is going to be letter B. All right, top of the next page for question number 4. Here we have one that deals with percentages, and I'm going to draw this out kind of, it's not really a Venn diagram, it's more like a tree diagram to hopefully help you understand it. So, and this is basically using picking numbers. So you have this piece of land, okay, 52% of it is farmland. So I'm going to say, okay, the piece of land is 100 whatever square meters. You can use whatever unit you want. Okay, 52% of it is farmland. So that means 52, again, use whatever unit is. This is farmland, and the remaining, which would be 48%, is prairie, open prairie. Okay, now, of the farmland, 21.5% is occupied by buildings. So I'm going to split this up and basically do 21.5% of 52. All right, 11.18. So that means 11.18, again, square meters, whatever unit you want to use, is buildings. And the remaining value, which technically doesn't matter, but I already did it. I think it should be, let me just check, 40.82. It's going to be first. Get rid of this. Get that out of there. 1 minus this. Parentheses, yeah, 40.82. Just 1 minus 21.5% times the 52. Okay. Now we can do the same thing for the prairie. So in the open prairie, 19% are occupied by buildings. All right. So that means 0.19 times the 48. So 9.12. Buildings, and the remaining amount, technically it doesn't matter. There's multiple ways you could do it. The easiest way is to actually just do 48 minus that. It's going to be 38.88. All right. What percent of the overall land is occupied by buildings? So now basically what we're looking at is, okay, this and this. So because I started with 100, I can just add these two together, and that's basically my answer, because technically you're just going to add them together, but then you're going to divide by 100, which is the total, but dividing by 100 won't change the value. It just moves the decimal place over. So we've got 11.18 plus 9.12. So the correct answer, at least for these specific numbers, is going to be 20.3%. So the answer you would select or you would fill in is 20.3 since they're asking for it as a percentage. This is, I think, the easiest way to do this problem, using this idea of picking numbers, like starting with a value of 100 and breaking it down like this. You could do this again, like theoretically, using like an X and then, 100 times 0.52 and then times 0.215 and blah, blah. But I think it's just much easier to see, to visualize, understand using actual values. All right, next up, question number 5. Here you have this equation which gives the value of the partial circumference of a circle. Notice 2 pi r here is the circumference, but this is, 2/3 of it. And we want to know for a 13-inch increase in the radius, how much does this equation, or the partial circumference, increase by? Essentially, it wants to know what k is here in this expression, k pi. All right. So again, easiest way I think to do this is basically just with picking numbers. So I would start with a radius of 0, and my partial circumference value would, of course, just be 0. All right, so now if I increase the radius by 13, whatever unit we're talking about here, 13 inches, now the radius is 13. So if you plug 13 into this formula up here, 2/3 times 2 pi times 13, basically you get 13 times 2, 26. 26 times 2 is 52. You get 52 pi over 3. So the C of R value increased by this much when we increased the radius by 13 inches. Okay? Therefore, this is what's equal to k pi. So what is the value of k? Well, the pi's cancel out. k is just 52 over 3, excuse me. So you could enter it in as 52 over 3. You could also put in the decimal equivalent form of 17.33. Either of those answers would be acceptable. And you can also just confirm this using other values. Like I'll just show you quickly in Desmos. If you just define the function, I'm going to use x instead of r. So we have 2/3 times 2 pi x. Okay, so now I'm just going to use 10 and 23. All right, so I start with 10 and I get this partial circumference value. Then I go to 23. I get a partial circumference value. Now I subtract these two, find the difference. Here's the thing that's tricky. Here's what you have to be aware of. Notice in the problem, they say, like for a 13-inch increase, i.e. the difference we're finding here, it's equal to k pi. So this number is equal to k pi. That means to find k, you have to take this value and divide it by pi. So in other words, I'm going to take this, divide it by pi, and notice now it gives me the 17.33 that I had as my answer. And if you click on this, it should give us, yep, fractional form 52 over 3. Okay, so this is just how you could do it out in Desmos and just confirm using other values that, yes, for a 13-inch increase in the radius, the change in this function is equal to 52 over 3 pi. All right, next up, number 6, we have another exponential function here. This one is asking for the basically percentage increase, percentage increase when you increase x by 1 in this function. Okay, this is actually a repeat question. This first appeared, I think it was back in June, the June problems that I did. But I'll show you two different ways to do it. First way is just a theoretical way. Second way is using actual numerical values and just finding it that way. So the first way is starting with x equals 0 and x equals 1 and comparing them. So basically, or actually no, sorry, no. It is not doing that. It's doing sorry, get ahead of myself here. It is taking the original function, okay, and then increasing x by 1, so just making it x plus 1, and now finding the increase. So 87b to the x plus 1, 87b to the x. And again, because it says it increases by c%, excuse me, that's percentage increase, which means we need to find the difference and then divide it by the old or the original. So now, a couple things. First of all, the 87s can all cancel out. Also, you can split this up into two fractions. So now if we split this up into two fractions, we're going to get b to the x plus 1 over b to the x minus b to the x over b to the x. Also, remember, we're going to have to multiply by 100 to turn it into a percentage. Okay, so notice here, b to the x over b to the x, that's just 1. Okay, b to the x plus 1 over b to the x, well, with rules of exponents, you subtract them. Sorry, you divide. When you're dividing, you subtract the exponents. So it's x plus 1 minus x. So this whole expression just simplifies to b to the first, or just b. So the correct answer to this, and again, this would basically be this would have to be a multiple choice question, would be 100 times b minus 1. Okay, so this is the correct answer you would select. Again, this would have to be a multiple choice question. Now, just to show you how you can confirm that this is correct using some actual numerical values, let's go to Desmos. We'll put in the function. Okay, I let b equal 1.5. And now I'm going to increase x by 1. So what I'm going to do is I'm going to find f of 1 and f of 2. And now find the percentage increase between them, basically, which is just f of 2 minus f of 1, and then divided by the original or the old, which is f of 1. Okay, now, of course, we have to multiply by 100, so that is 50%. So what you would do now is you would go to the various answer choices, and you would plug in the b value of 1.5, and then you would work out the expression, and you would see which one gives you a value of 50. Okay, the answer we got is going to be correct. 100 times b minus 1, right here, it gives you 50. Okay, so that's just confirmation that this is the correct answer. But again, you would go to the answer choices, you plug in the b value I chose, and then whatever answer you got would be, or whatever one is equal to the answer we got, 50, is what would be your correct answer. Moving now to the top of the next page, problem number 7. Here we have another exponential function type problem. And there are two ways you can do this. There's basically the traditional way, and there's also just going to Desmos and doing it in Desmos. I'm going to show you both methods, of course. Also, just note this is a repeat problem. This appeared on a previous exam. I think it was last month. I think it was November, but it might have been October. So, traditional way to do this would be just to plug in these point values. So, for example, 4 equals a to the c minus b, and 114 equals a to the 2c minus b. All right, once we have that, what I'm going to do is I'm going to solve this first one for a to the c. So a to the c is just equal to b plus 4. Just add b to both sides. And I'm going to plug that in to the second equation. So a to the 2c can technically be rewritten as a to the c quantity squared, because when you raise an expression to an exponent, you're just multiplying the exponents together. So I can split it up like this. And if I do that, then the a to the c can just be replaced with what it's equal to from the other equation, which is just b plus 4. So I've got b plus 4 squared and then minus b still equal to 114. If you square this out, it's going to be b squared plus 8b plus 16, and then minus b. And also, I'm just going to go ahead and subtract the 114 over. So now it's equal to 0. So we've got b squared, looks like plus 7b, and then 16 minus 114 is going to be negative 98. Now this you could solve either by factoring, or you could just type into Desmos, look for the x-intercepts, either way. It's going to be b and b. If we factor it, we know it's going to be plus and minus for the two factors of 98, and they're going to turn out to be positive 14 and negative 7. So now when we set each of these factors equal to 0, we're going to get b equals negative 14 or b equals positive 7. So b equals negative 14, not listed there. B equals positive 7, yes, is listed there. So that's the correct answer. It is letter B. Now, here's how you could solve the entire problem in Desmos. I'm going to shrink this down a little bit so we can see the problem. So all I'm going to do is I'm going to make a table. I'm going to put in my 2 points that were given. Then I'm going to add a slider for C. Then I'm just going to do regression on an exponential function. Okay, so notice here, okay, we have an A value of 11. That doesn't really matter. We have a B value of 7. So that checks, we get the same exact answer. Notice what's going to happen here is as I move the C value, the value for B does not change. It stays fixed at 7, okay? It does not move to any other number. The A value obviously changes, the shape of the graph changes, but the y-intercept does not change. Now, if we move it to even numbers between 0 and 1, same thing still happens. Even if we move it to negatives. So, over here, notice the b value is still 7. Okay, it doesn't matter. So this is how you could do it in Desmos. Um, probably quicker than doing this all out by hand, but still get the same answer, letter B, 7. All right, next up, we have a problem that just basically asks about the, your knowledge of similar right triangles. So you have two right triangles here. You're told the triangles are similar. Okay, we know that y and s are the right angles, so I'm going to label this y and this s, and then we'll call this x and z, and since they have to correspond, we have to put r up here and t down here. All right, we know that angle z is 20 degrees, and it wants to know what's the measure of one of the acute angles in triangle RST. So basically, angle T is going to be 20 because it has to be congruent to angle Z since the triangles are similar. So one possible answer is 20. And of course, angle R would have to be 70 degrees because if you add up all three angles in a triangle, it adds up to 180. So 20 plus 90 is 110. 180 minus 110 would be 70. This angle, of course, obviously would also be 70. So you have two possible answers you could fill in here based on the way that this is worded. You could either report 20 or you could report 70. Either one would be correct. All right, for number 9, we have another repeat question. So for this one, you have this equation and it's got two constants in it. It's got k and a in addition to your variable x. And you're told the sum of the roots is equal to this expression with k in it, and it wants to find the value of a. So the quickest way, the easiest way to do this that I've seen is not to take the left side and square it all out and then multiply out the right side and combine the terms, blah, all that stuff. It's actually to essentially bring this whole term over to the left side. So you have x minus k squared minus k minus 5a times x minus k. Then factor out a common factor of x minus k. All right. So for the first, from this first quote term, what you're going to have left with is just x minus k. Then from the second term, this comes out, you're going to be left with minus k minus 5a. Now you can combine these in here. So notice we have x minus 2k, negative k minus k, plus 5a. And the first thing we have, of course, is x minus k. Now, since these two parentheses are equal to 0, I can technically set each of them equal to 0, solve for x, and those are my two roots. And then I'm going to add them up, set them equal to the 3k plus 33. So the first one, obviously, it's just going to give x equals k. X minus k equals 0, add k to both sides. That's your first root. Second one, essentially what you're going to do is just add 2k to both sides and subtract 5a. So x equals 2k minus 5a. So that's your second root. So we're going to add that to the first root of k, and again set equal to 3k plus 33. Notice here, these make 3k, and now the 3k's are actually going to cancel out. That's what's going to allow you to solve this equation for a. And it's going to be negative 33 over 5. So, correct answer is negative, like I said, negative 33 over 5. You could also enter it as negative 6.6. I do not know of a way to solve this entirely in Desmos. I mean, we can use Desmos just to check and confirm that the answer is correct by typing in the equation. Okay, so first I'm going to set a equal to 33 over 5. Now, in order to actually get some answers, what I have to do is I have to just, pick a value for k. So, let's see here what we get for our answers. So, okay, let's say I let k equal 1. I get two answers. Okay, I get 1 plus negative 31. So the sum of my two roots is equal to negative 30. Does that equal 3k plus 33? Let's see here. 3k plus 33. No, it does not. So what's going on here? What's the issue that's happening? Oh, sorry, it's negative. This is the whole issue. Right here. Now we're fixed. Now we've got 35 and 1. 35. Now, yes, do the sum of my two solutions or my two roots equal the expression 3k plus 33? Yes. And we could change this. And here we get 38.4 and 2.7. So you'd have to manually type in 38.4 and 2.7. 41.1. Does that match 3k plus 33? Yes, 41.1. So you can check it in Desmos, but again, I don't know of a method to just solve the entire problem in Desmos. All right, the last question on this December 2024 Digital SAT Math problem set number 2. Fairly complicated question, but it's actually not that bad once you take a look at it. So essentially what's going on here, this one, I don't know if they maybe gave you the picture or they just described it, in words, but essentially what you have is you have a sphere, and this is obviously not 3D, this is just, 2D, so it's a circle, but you have the sphere, and then inside the sphere you have a cone, all right? So the radius of the sphere is 35. That means all the way across here at the middle, the diameter would be 70, which means that tells you that the cone, I guess there would have to be some way to let you know whether it's above or below the diameter point of it. Because the way I set it up, the way I solved it was I drew the cone down here, going to the top. Okay, and then coming down, we know that the, let's see, diameter of the cone is 56. So that means all the way across here is 56, which means this is 28. All right, so they want to know, basically want to know what the volume of the cone is. So formula for volume of cone, 1/3 pi r squared h. So we need the radius of the cone. Well, that we actually already have. It's 28, but we need the height of the cone. Okay, we need this total distance right here. Now, the way we're going to find that is actually by setting up a triangle, right triangle specifically, right here from the center of the sphere. Because now we have a right triangle and we know one side is 28 and we also know this hypotenuse is 35. The reason we know it's 35 is because this is just a radius. Going from here out to the edge of the sphere, that's just a radius of it. So we know the radius is half the diameter, the radius is here, they give us, it's 35. So we got 28 squared plus whatever it calls x squared equals 35 squared. This, we can just go to Desmos, we can just solve it right in there. Get rid of all this. I'm just going to use regression. Okay, so, oh, I forgot to square it. There we go. Sorry, we want, 21. So, therefore, this distance right here is going to be 21. Now, we can add that to this distance right here, which again, this is a radius of the sphere, which is 35. That gives us the total height of the cone as 56. Therefore, the volume is going to be 1/3 times pi times 28 squared times 56. So if you go ahead and just multiply this all out, we can just do it in Desmos. It should come out to 14,634.66 pi. And the k value they're looking for here is the number that's multiplied by the pi. And it says about rounding it to the nearest whole number, so it should be 14,635. Let's just go to Desmos to confirm. Slide this up. 1/3. Okay, technically I'm just going to ignore the pi because that, we don't need that. We just need everything else besides that. All right, so yep, there we get 14,634.666, 2/3. And again, we can round that just to 14,635. So that should be the answer to this question. So just to talk about this problem now, one last thing. If you had the opposite scenario to where, like, say the cone was up here, then I'm trying to think how we would do this. I guess you would kind of do the opposite method, which would be like we know that the diameter of the cone is 28. We know this is a radius. So this would be the 21. Basically, these triangles are like mirror images of each other. And we know this whole thing is 35 because this is a radius. Therefore, this right here, this distance from here to here would be 14. So if that were the case, then everything would be the same except now your height would be 14 instead of 56. So you'd be doing 35 minus 14 instead of previously we did, or sorry, excuse me, 35 minus 21 to get 14 instead of 35 plus 21 like we did last time. So then you could work it out and you get whatever number and you'd round that and everything. So for this problem, I guess maybe they had to give you the picture or else they had to somehow describe or basically tell you that the base of the cone is like below essentially the halfway point of the sphere, in order to know that it was set up like the first way that I did it. Anyways, I hope you enjoyed this video, the second problem set from December 2024 digital SAT math exam. If you have any questions or comments or alternate solution methods, please do leave them below in the comments. Otherwise, again, if you do like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. If you haven't done so already, check out part 1 from the December 2024 digital SAT math section. And once it's posted, also be sure to check out part 3 for 10 more problems. But otherwise, again, hope you enjoyed this video, and I'll be back with more digital SAT math related content soon.